I'd like to do some examples using what we learned about types of reactions to predict what's being made in a reaction. Let's just go through a handful of examples here. Well, before we do, let's review what we know from our types of reactions. We've got 5 different types. We've got our combination or synthesis, where we've got a general of 2 elements being combined into a compound. We've got your decomposition, which is a compound being broken apart into its constituent elements. We've got a single replacement, where we've got an element reacting with a compound to give us a separate element that gets kicked out, and it can either be the cation or in the anion. In this case, I'm kicking out the cation, and a new compound, combination of my original element and the anion. A double replacement, where we switch partners. So the cation gets together with the anion, and the cation gets together with the anion. And then last but not least, combustion reaction. Some general fuel or hydrocarbon reacts with oxygen or is burned in oxygen to produce either carbon dioxide and water, or it can produce carbon dioxide, water, carbon, and carbon monoxide. So those are our general forms of our equation. So let's go ahead and take a look at a couple of examples here. Let's do this first one here. I've got fluorine reacting with lithium chloride, so I've got fluorine gas, it's F2 because it's a Hunkelbrief, reacting with lithium chloride, LiCl. Lithium's got a positive 1 charge, chloride's got a negative 1 charge. To produce, I don't know what this is going to produce. I've got to predict what's going to be made. So I'm going to look through my patterns and see what type of reaction this is. I've got an element reacting with a compound. I look down, element reacting with a compound is a single replacement. In this case, I've got fluorine, which can only replace the anion, so it's going to try to replace chlorine. So what I need to take a look at is the activity series to see if this will actually occur. Remember that an element can replace anything below it in its particular list. I've got a cation list. I've got an anion list. I know fluorine can only, is going to replace chlorine. They're in this list over here. Fluorine is above chlorine. Fluorine can replace anything below it. So fluorine can indeed replace chlorine. So this reaction will occur. So what winds up happening is chlorine gets kicked out on its own, and we get lithium fluoride. And then, of course, we need to balance this. And again, it's lithium fluoride because lithium has a +1 charge. Fluorine has a -1 charge. Add these guys up to 0, it's 1 to 1. So balancing, I'm going to wind up with a 2 here and a 2 here, and it's nice and balanced. Let's take a look at this next example. Again, I'm going to write out my equation, my formulas. I've got potassium fluoride, which would be Kf, because potassium's got a +1 charge. Fluorine's got a -1 charge. Add those guys up to 0, and it's 1 to 1. Calcium nitrate, Ca2+, nitrate, NO3 with a -1 charge, so it's going to react with CaNO3 2 to produce, again, I don't know what it's going to produce. I'm going to need to predict that. I've got essentially AB plus CD. I recognize that as a double replacement reaction. It's right here. So what's going to happen is the cation is going to get together with the anion, so it's going to give me KNO3, +1, -1. I just need one of each, so that's my formula for potassium nitrate. And the cation and the anion. So it's going to be CaF2 because fluorine's got a -1 charge when it forms its ion. Calcium's got a +2 charge. So I need 2 of these to add up to 0 to add with this +2. That's what's produced. I still need to balance this, so I'm going to go ahead and balance this. Going to need a 2 here and a 2 here, and it's all balanced up. All right, so let me copy this onto the next page. For our next examples here. So I don't have to rewrite this. Okay, so I've got my set of equations here to my general equations for my types to work from. I'm told this is a combination reaction. It says a combination reaction between sodium oxide and water. Keep in mind with combination reactions, I've got a couple of specific or special ones. I've got a metal oxide and water will give me, well, let's go back and take a look at our types of reactions packet here. Metal oxide and water is going to give us a hydroxide. It's going to give us a hydroxide. So let's see here. It's going to give us a metal hydroxide as our product. So let's go ahead and start our reaction here. I've got sodium oxide, Na2O, reacting with water, H2O. That's going to combine to form a hydroxide. Remember, hydroxide is OH minus. So I'm going to wind up with my metal. I guess I should write that down. Metal hydroxide. My metal is sodium. So I've got NaOH because my sodium has a +1 charge. So I've got sodium hydroxide as my product in this combination reaction. So to balance this up, looks like I need a 2 here, and I think that does it. 2 sodiums, 2 sodiums, 2 oxygens, 2 times 1 gives me 2 oxygens, 2 hydrogens, 2 times 1 gives me 2 hydrogens, and I'm done. Let's take a look at this next one. We're told this is a decomposition reaction. I'm told the decomposition of copper hydroxide. So I'm going to go ahead and write out my formula for copper 2 hydroxide. That's going to be CuOH2. That's going to produce, now there's a special decomposition for this. Let's go ahead back to our notes packet. Metal hydroxides, which is what I have, metal hydroxides will form a metal oxide and water. So I'm going to break that down into a metal oxide and water. So we know that metal hydroxides, essentially what we're doing is we're doing the reverse of the reaction that we just did. Metal hydroxides will decompose into a metal oxide and water. So my metal is copper 2, so it's going to be CuO, metal oxide, Cu's got a +2 charge for my copper 2, and then oxide has a -2 charge, so that'd give me my copper oxide and water, H2O. Balancing, looks like this is balanced already. I've got 1 copper, 1 copper. 2 times 1 gives me 2 oxygens. I've got 2 oxygens here, 2 hydrogens there, and I'm done. Let's go ahead and go to my next example here. I'm told that methane burns completely in oxygen. Let's go ahead and see if I can. Whoa. There we go. Bring those with us. So we've got these to refer back to. Methane burns completely in oxygen. Keyword here is burn. Burn is another word for combustion, which is this reaction down here. We're told completely, so that would be our complete combustion, so it's going to produce carbon dioxide and water. That's always going to be true. So what I've got is, I've got methane, CH4, reacting with oxygen to produce, well, it's complete combustion, we're told that, so it's going to produce carbon dioxide and water. All that's left to do is balance this. One carbon, four hydrogens. I've got two hydrogens over here. I need to double that. So I've got four hydrogens. My oxygen, I now have two oxygens plus another 2 times 1 gives me 2 oxygens, so that would be a 2 here, and I'm all balanced up. Take a look at this last example. Silver is placed in a solution of nitric acid, so I've got silver reacting with nitric acid, HNO3. I don't know what this produces, but I can see that this is an element reacting with a compound. Element reacting with a compound again is back to this reaction here, a single replacement reaction. What we need to do is we need to go back to that activity series. So let's take a look at that activity series. I've got silver down here, and it's going to try to replace hydrogen out of nitric acid. Silver can only replace what is below it, not going to replace hydrogen. So, oh, whoa, don't want to hold that back. That'll blow my head off. Excuse me. So what we're going to write here is this reaction won't occur. Sulfur cannot possibly replace hydrogen from nitric acid. So what we're going to write here is no reaction. RXN is an abbreviation for reaction. Handful of examples here. Constantly refer back to these this set of patterns, this set of general equations for different reactions. Keep in mind we've got a couple of special things that we have to remember for single replacement and double replacement. Excuse me, not single replacement, double replacement for combination synthesis reactions and combination synthesis reactions and decomposition reactions. Remember that our non-metal oxides in water are going to produce acid. Metal oxides in water are going to produce hydroxides for combination reactions. And for decomposition, metal carbonates will break down into metal oxides in water, or excuse me, in carbon dioxide, and metal hydroxides are going to break down into metal oxides in water. Those are some specific patterns within our general pattern for decomposition and combination. Also remember that for single replacement, we need to pay attention to the activity series to decide whether a reaction is going to occur or not.